Okay, so hi everyone, Senan this side, and in this video we are going to see how to solve this LeetCode daily problem, which is delete nodes from a linked list present in an array. Okay, so you are given an array of integer nums and the head of a linked list. Return the head of the modified linked list after removing all nodes from the linked list that have a value that exists in nums. So quite straightforward. You have to just perform a delete operation, but there are some constraints that you have to take care of. First of all, the node that you delete should be present in this nums array, and whatever is the remaining linked list, you have to return that. If you see 1, 2, and 3, and you see 1, 2, 3, 4, 5, so you remove the first three elements, so 1, 2, and 3. So what you're left with is 4 and 5, so you return that. So the other case, you see this one, we'll do a dry run on the, what do we say, in our notebook. So I'll leave this for now. If you see this, nums of 5 is what it does not exist in the linked list, so we return the linked list as it is. So all elements in nums are unique. The number of nodes given linked list is this. Okay, so anyways, whatever is the thing, what we are going to do is, first of all, whenever we are at a node that we have to delete, we need to figure that is this value present in the nums list. Okay, so every time you go into this, either you could search through the array itself, right? So let's say the linked list has a size of m and the nums size is n. So for this node, you'll check for n times. For this node, you'll check for n times. This node you'll check for n times, and so on and so forth. So the time complexity in that case would be n times m. So you understand that deleting is a constant time operation. Let's assume. So if you if for every node you have to do a linear search, so can you optimize that or not? That's the first question, because anyways, to delete an element from this linked list, you have to traverse this linked list at least once. So the base case or the best time complexity you could get is linear time, which is big O of m, assuming m is the number of elements in the head. So if that is the case, and the worst case or the brute force approach would be to m times n. So your answer is somewhere between m and m times n. Now, if you know, whenever in doubt, throw a hash map or hash set. That is what we are going to do. So that I'll put all of these elements in a set. So what that will do is reduce my searching time to big O of 1. Obviously, the worst case is big O of n, but that won't be the case more or less. Okay, so for searching if an element exists in this nums, what I could do is basically create a set and store all the elements in nums in that set. So we have improved our searching. Now, how are we going to delete it? How are we keeping track of what elements to keep and what elements we should not keep? So one way could be either first iterate through all the list and find all the elements which are not present in nums, and then create a new linked list and then return that linked list. That's one way. I'm saying that we are not creating a new linked list. We will just reassign this pointers of this linked list so that we get the job done. So no new nodes, no new linked list would be created for this case. Now the way I would do it is using the concept of dummy nodes, and using that dummy nodes I have to save a node or to delete a node. So nodes present in nums is, I'll call that the nodes that needs to be deleted, and which are not in nums are the nodes that we have to save. So let's look at the dry run for the explanation, then we'll look at the code. Okay, so here is the example, and I know in the uh, problem, the test case, there was one more 2 I think in the end, and this was pointing to null, but let's do it with this. So first of all, what I would do is I'll take two dummy nodes. One is TS, one is TD. TS stands for to save, TD stands for to delete. Now what I'll do is I'll perform the iteration. I'll look at this first node and I see my nums is exactly 1, right? So I have this one present in this. So that means this is the one that we have to delete. So what I'll do is I'll take a pointer to this and I'll point to this. And I'll say that this is TD. And now I'll look at the next node. Now this 2 is not in this nums list, so that means this is the node that we have to save. So what I'll do is I'll take this, I'll just remove this head for a moment, and I'll take this to save and I'll point this to 2. Okay, now after that I'll look at the third node and see again this is present in my nums array, so that means this is something that we have to delete. So what I'll do is I'll take the pointer from the to delete node and point to this node. And since I'm doing this, I have to delete this pointer. Okay, and this 2 is now to save, and to save is now here. After that, I'll check for this 2. So this 2 is not in this nums list, so that means we have to save this. So I'll say this is my to save, and I'll assign this pointer here. And for because I did this assignment, I have to remove this pointer. I have to remove this. So this node is to delete, and this is to save. Now you take this, you check for this next node is 1, and 1 is what? 1 is present in the nums, so that means we have to delete this node. So I'll take this to delete and point it to here to delete, and I'll reassign the link like this. Okay, and what I'll do in the end, I'll after the to save and to delete, I'll mark the next as null for both of them, regardless if it was or not null. Now if you observe, we now have two lists, and the two list looks like this to save list looks like this. Let's say dummy node initialized to -1 and -1. So -1 2 2, and to delete is what? It's -1 1 comma 1 comma 1. So these are the two linked lists that we have. And in the end, what I'll do is I'll update the head of to save to this one, and I'll return this. And before that, I have to delete all these nodes because we had to delete that. Now this explanation is more than enough. Basically this did not require any explanation, that is what I think. But anyways, now let's look at the code, so that would help you understand this better. Okay, here we are back in my profile. So first of all, what I do is I create an unordered set, and that will store all the elements in this nums array. And this is just because we have to improve the searching time, right? Now I create two dummy nodes initialized with -1, both of them, and I say marker 1 is equal to save, and marker 2 is equal to delete. That is just to keep track of the head of this to save and to delete. Now I take a temp variable and temp pointer, and I'll say while temp is not null, I'll take the value in that node and I'll try to find that in my set. So if while finding if my set is equal, so if this statement is true, that means I did not find that element in my set. So that means this is the number that we have to save. To save's next is this temp, and to save is now updated to temp. I'm just reassigning the to save and reassigning the pointers. Otherwise, if it is a node that if statement is false, that means we have found this element in the set. That means it's present in this nums list. So what I do is I say to delete's next is this temp, and I update the to delete to this temp. And after this, I'll just update the temp is equal to temp's next. Now the last node could not have a null in the end, so I manually just assign null to both of them. Whichever is not null, we could assign both of them to null, because we now have two linked lists basic. Now if you see, the marker 2 is what? The to delete one, right? So what I'll do is while marker 2, I'll assign temp, because temp is no more used required in this while loop, so I can reuse this temp. I say marker 2's next, right? I point this to the next node, and I delete this current marker, and I update this marker 2 to the next node. So this while loop is basically deleting all the nodes in the to delete linked list. Okay, now to save, the node that we have to save is I reassign it to the new head of this list, because the first node is -1, right? So I don't need the -1, I just need the remaining portion. So I'll say to save is marker 1's next, and I delete the marker 1, because we have to delete, because we have manually initialized two nodes, right, to save and delete. So this is the delete for marker 1, and marker 2 would be deleted with the nodes in the linked list that has to be deleted. And in the end, you return the head of this new created linked list, where we just reassign the links, and this is what we do. If you see, this is working pretty well, and it's accepted as. So yep, that was the whole video. Not much to discuss in this, but hope I was able to explain you, and I'll see you in the next video.